Optics. 2.4 Scattering of light. When sunlight enters the Earth's atmosphere, the atoms and molecules of different gases present in the atmosphere refract the light in all possible directions. This is called as scattering of light. In this phenomenon, the beam of light is redirected in all directions when it interacts with a particle of medium. The interacting particle of the medium is called a scatterer. 2.41 Types of scattering. When a beam of light interacts with a constituent particle of the medium, it undergoes many kinds of scattering. Based on initial and final energy of the light beam, scattering can be classified as 1. Elastic scattering. 2. Inelastic scattering. 1. Elastic scattering. If the energy of the incident beam of light and the scattered beam of light are same, then it is called as elastic scattering. 2. Inelastic scattering. If the energy of the incident beam of light and the scattered beam of light are not same, then it is called as inelastic scattering. The nature and size of the scatterer result in different types of scattering. They are 1. Rayleigh scattering, 2. Mean scattering, 3. Tyndall scattering, 4. Raman scattering. 1. Rayleigh scattering. The scattering of sunlight by the atoms or molecules of the gases in the Earth's atmosphere is known as Rayleigh scattering. Rayleigh scattering law. Rayleigh scattering law states that the amount of scattering of light is inversely proportional to the fourth power of its wavelength. The amount of scattering is proportional to 1 by lambda power 4. According to this law, the shorter wavelength colors are scattered much more than the longer wavelength colors. When sunlight passes through the atmosphere, the blue color of shorter wavelength is scattered to a greater extent than the red color of longer wavelength. This scattering causes the sky to appear in blue color. At sunrise and sunset, the light rays from the sun have to travel a larger distance in the atmosphere than at noon. Hence, most of the blue lights are scattered away and only the red light which gets least scattered reaches us. Therefore, the color of the sun is red at sunrise and sunset. Main scattering. Main scattering takes place when the diameter of the scatterer is similar to or larger than the wavelength of the incident light. It is also an elastic scattering. The amount of scattering is independent of wavelength. Main scattering is caused by pollen, dust, smoke, water droplets and other particles in the lower portion of the atmosphere. Main scattering is responsible for the white appearance of the clouds. When white light falls on the water drop, all the colors are equally scattered which together form the white light. Third one, Tyndall scattering. When a beam of sunlight enters into a dusty room through a window, then its path becomes visible to us. This is because the tiny dust particles present in the air of the room scatter the beam of light. This is an example of Tyndall scattering. The scattering of light rays by the colloidal particles in the colloidal solution is called Tyndall scattering or Tyndall effect. Fourth one, Raman scattering. When a parallel beam of monochromatic, that is single colored light, passes through a gas or liquid or transparent solid, a part of light rays are scattered. The scattered light contains some additional frequencies or wavelengths other than that of incident frequency or wavelength. This is known as a Raman scattering or a Raman effect. Raman scattering is defined as the interaction of light ray with the particles of pure liquids and transparent solids which leads to a change in wavelength or frequency. The spectral lines having frequency equal to the incident ray frequency is called a Rayleigh line, and the spectral lines which are having frequencies other than the incident ray frequency are called Raman lines. The lines having frequencies lower than the incident frequency is called Stokes lines. and the lines having frequencies higher than the incident frequency are called anti-Stokes lines.